This lesson will review two things: differences and arithmetic sequences, they go together, and then secondly, ratios and geometric sequences, and those two things go together quite nicely. So let's start by considering the difference. When we talk about the difference between two numbers, what we mean is what you get when you subtract. So, for example, if I told you that, this example actually comes out of your book, that the tuition at a certain university last year, let's say in 2010, let's say that the tuition was $20,000 a year. And now in 2011, the tuition has changed, and it's now $23,000. So if I ask you what is the difference in the tuition, well, what happened? It went up $3,000. Those numbers, it's pretty easy to do in your head, but the procedure that always works to find that difference, I'll use a D for difference. You do now, that means what is it now? Well, in 2011, it's 23,000, and the previous amount was 20,000. So you do that subtraction problem, and you get 3,000. So the difference between last year's tuition and this year's tuition is $3,000. I guess I should really have dollar signs, on all of these. Sorry about that. Now, notice that if something increases, the difference is positive. Okay, here's another example. Suppose that the value of a car in 2010 was $7,000. And then a year later, in 2011, the value of the car is now $5,000. Okay, in this case, if you do now minus previous, it's now 5,000. It used to be 7,000. And notice in this case that the difference is negative. Okay, so if something is decreasing, the difference will be negative. If it's increasing, the difference will be positive. So that's a basic description of difference. Okay, the ratio of two numbers can be found by dividing. So for example, suppose I told you that in 2010 I paid $15,000 for my travel. That's a lot of money, but let's say that's what I did. And then suppose in 2011 I really went on a lot of vacations and I spent $45,000. Okay, this time I don't want to know the difference. The difference could be found by subtracting. I want to know the ratio. How many times greater is the amount in 2011. So to find that ratio, R is for ratio, I take the amount I have now, which in this example is 45,000, and I divide it by the previous amount, which was 15,000, and I get a ratio of 3, which essentially means I spent 3 times more money. It doesn't tell you how much more I spent, it just tells you that I spent 3 times more. Now, what if something is not increasing but decreasing? Okay, suppose in 2010, I traveled, let's say, 10,000 miles. And then in 2011, even though I spent more money, suppose I only traveled 5,000 miles. The ratio in this case, well, the now amount is 5,000. The previous amount was 10,000. And if you reduce that, you get 1/2 or 0.5. So the ratio is now 1/2. Notice that it is a fraction smaller than 1. I went half as many miles. So again, if the numbers are growing, the ratio is going to be bigger than 1. If the numbers are getting smaller, the ratio will be less than 1. All right, now, these concepts are going to be used to describe certain sequences. But first, let's just talk about what a sequence is. It's an ordered list of numbers. Each number in the sequence is called a term. The simplest sequence I know is 1, 2, 3, 4, and so on. It'd be very easy to come up with the next terms in the sequence. You would just go 5, 6, 7, 8, and so on. Now, some sequences, on the other hand, are way more complex. The one that I have listed here, 1, 1, 2, 3, 5, 8, 13, 21, is a very famous sequence called the Fibonacci sequence. Stare at it and see if you can figure out the pattern there. I have to tell you that the first time I saw this one, I couldn't figure it out. I needed a hint. I'm not going to give you that hint now, but we can certainly talk about that in class next time. Okay, so, now, some sequences are common enough to earn a special name. So an arithmetic sequence is one where the difference between each term and the previous is always the same. All right, so let's look at an example. Suppose the first term is 5, and the next term is 7, and the next term is 9, and the next term is 11, and so on. So just think, what would the next term be? Hope you said 13, and then after that, 15, and so on. So notice that to go from 5 to 7, it's an increase of 2, 7 to 9, also 2 more, and so on. So the common difference here is, well, you can take any term and subtract the previous one to find the common difference. It works with, you could start at the 13, subtract the previous term, you still get 2. And that's what an arithmetic sequence is. It's one where the difference between successive terms is always the same. In the interest of time, I'm not doing an example, but if the terms were going down, then the difference would be negative. Now, your book goes through a very standard notation. I'm just going to show you briefly, but we'll talk about this more in class. I could describe this sequence by saying the first term, I'm going to call it U1, is 5, and then I can give a rule. To get the next term, I take the previous term and add 2. All right, that notation might be new and unfamiliar. I'm introducing it now. Just know that I'll go over that in class in more detail. Okay, let's see about a geometric sequence. This is one where the ratio between successive terms is always the same. So, for example, 5, 10, 20, 40. What do you think's next? Hope you're thinking 80 and then 160 and so on. So if I asked you to describe in words what's happening, well, you added 5 and then, wait a minute, we didn't add 5 again. So it's not arithmetic because we're not adding the same amount each time. Instead, we are multiplying by the same amount each time. 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and so on. Now, to find the common ratio, you can take any term, let's say 20, and divide it by the previous, and you get 2. That's going to work with any term. If you take the 80 and divide it by the previous term, 40, you get 2. So each term is twice as big as the one before it. Keep in mind, if the sequence is decreasing, then your ratio is going to be a fraction, like 1/2 or 1/3. Now, we can do the same thing that we did with the arithmetic sequence. Oops, sorry about that. We can define it abstractly by saying, let's see, U sub 1, I'm going to specify that the first term is 5. Then I'm going to say to get the term n plus 1, you take the term n and you multiply by 2. All right, again, we'll go over that in greater detail in class. I'm just introducing that quickly so you've seen it. All right, your homework. Actually asking you to do 2 problems out of the book from page 29, numbers 1 and 3, and that's addition 2. If you have addition 1, you can find those problems in the online version of the book. Then after you do those 2 problems, I've listed 1, 2, 3, 4 sequences. Please identify each of those sequences as arithmetic or geometric. And then if it's arithmetic, tell me the common difference. If it's geometric, tell me the common ratio. Okay, so pause this video if you need to copy down those problems because it's just about over.